In the previous video, we talked about how to find the length of a portion of the circumference. We called that a circular arc. In this video, we're going to be taking a look at the same idea of a portion of a circle, but this time we're going to be talking about the area. When I draw an arc like that, it sort of cuts off a portion of the circumference, but it also, if I look at the central angle, cuts off a portion of the entire circle, a portion of the area. When I derived the formula for the circular arc, I mentioned that the portion of the circle represented by the angle theta was just a fraction of the entire circle. The same thing is true here. This fraction here, this ratio, represents the percentage of the circle that this angle represents in comparison to the whole circle, 2 pi, or 360 degrees. Again, we're working in radians here, so I'm going to go ahead and call it 2 pi. That percentage of the circle times the area of the circle will be the area of just this region here. Well, the area of a circle I'll put an X there instead of a dot. It's a little easier to see. Well, the area of a circle is pi r squared. If I cancel the pi's, I get theta times r squared over 2, or 1/2 r squared theta, depending on your preference for writing it. Your textbook has it in this form. So here's another formula you might want to write on a note card. The area of a sector is 1/2 r squared theta. If you know the radius and the angle, then you can figure out what the area of this portion of the circle is. Here's an example. Find the area of a sector of a circle with radius 4 meters and a central angle of 120 degrees. Let's draw this quickly. My radius is 4. It's 4 meters, but it's 4. And the central angle is 120 degrees. Well, 120 is more than 90, but less than 180. So it's something like this, just a ballpark. So I'm looking for the area of this sector here. I also know that my central angle is 120 degrees. Again, it's tempting just to write down the formula and substitute, let's put it over here, substitute the values I know. 1/2 times 4 squared times 120 degrees. That would be area equals 1/2 of 16, or 8, times 120, which is 800 plus 20 times 8 is 160, and 800 is 960. Now, one thing I've done kind of intentionally here is forget the degree symbol here. I can't really measure 8 times 120 degrees and end up with an area. So this would be 960 degrees, but this doesn't make sense. What's wrong with it is that I've used degrees in my formula. The formula is derived using theta as a portion of 2 pi, or radians. So I have to convert to radians first. I'll do my scratch work. I think I'll do my scratch work here, and then I'll redo the problem over here. I'm given 120 degrees, and I want to multiply that by 1. And I want to use the form of 1, the version of 1, that will let me cancel my degrees. I have pi over 180. I'll cancel my degrees. I'll cancel my tens. And then I have 6 goes into 12 twice, and 6 goes into 18 3 times. So 120 degrees is 2 pi over 3. So now if I do my formula again, I have 1/2 times 4 squared times, this time I'm using radians, 2 pi over 3. 1/2 of 16 is 8 times 2 pi over 3, which is 16 pi over 3, and that does not reduce. So this is my answer. 16 pi over 3 is approximately 16.755. I'll just call it 16.8 because I'm kind of out of room otherwise. And that's very different from 960. If you think about it, the area of this entire circle is pi times r squared. That's 16 pi. And 16 pi is 50.3, roughly. 50.3. That's the whole circle. We do that in a different color. The whole circle here has an area of about 50. So it's not possible for my area of a portion of that circle to be 960. That's just not right. Okay, so again, you have to be very careful to make sure that when you're using this formula, you're using radians. I'll highlight this. This is another one of those things that you want on a note card, if you're the kind of person who likes to use a note card. And that's how you find the area of a portion or a sector of a circle. Notice that just like the other formula that we derived, we can also, I'm going to write this just as a sub s now. If I multiply both sides by 2 and divide by r squared, I get 2 times the area of a sector divided by the square of the radius is equal to the angle. So in this case, if I know the area and the radius, I can find theta. If I know the area and theta, the area of a sector times 2 divided by theta equals r squared. So the square root of this is equal to the radius. So if I know the area of the sector and the angle, then I can find the radius. Again, you don't need these other versions of the formula. You just need this one, and I've rewritten it here with just a sub s. Notice when I worked this problem out down here, I wrote a sub c. That's the area of a circle. This one's the area of a sector.